A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So Daniel sent us this one, and it is a doozy. He wants us to check out a GitHub repository by Hezem Sheikh called Awesome OpenClaw Use Cases and report back on what people are actually doing with this thing. And look, we have talked about the sheer scale of OpenClaw before, the 16.5 trillion tokens it is chewing through every single day, but seeing the actual breadcrumbs of what that looks like in practice is a completely different animal.
It really is. And I have been diving into this repo all morning, Corn. It is essentially a curated cookbook for moving beyond just chatting with an AI and toward full, unhinged autonomy. We are talking about 47 distinct projects right now. Last I checked the March 2026 update, and they range from infrastructure management to creative content factories. By the way, quick shout out to Google Gemini 3 Flash for powering our script today. It is helping us parse through this mountain of data.
I love that we are using one AI to help us talk about the massive token consumption of another AI. It is very meta. But seriously, Herman, 16.5 trillion tokens. That is a number that is hard to wrap your head around. To put that in perspective, if every token was a grain of sand, you'd be looking at a beach that stretches from New York to London, and OpenClaw is walking across that beach every single day. If you are a developer or even just someone interested in where the plumbing of the internet is going, you have to look at this repository because it shows the transition from AI as a tool to AI as a colleague, or in some of these cases, an entire IT department.
That is the perfect way to frame it. Most people still think of OpenClaw as a chatbot or maybe a sophisticated coding assistant, but this repository reveals it is being used as a massive-scale processing engine. One of the most intriguing patterns I noticed right away is the real-time semantic search use case. We are seeing companies use OpenClaw to index live data streams with sub-millisecond latency.
Sub-millisecond? That is genuinely fast. I mean, usually when you talk about semantic search, there is a significant overhead because the model has to vectorize the input, turning words into these complex mathematical coordinates, and then you have to do the nearest neighbor search across a massive database. How is OpenClaw pulling that off at the scale of live streams?
It comes down to that parallel processing architecture we have touched on before. Instead of a linear pipeline where data goes in and a result comes out, OpenClaw is essentially pre-digesting tokens in parallel. In one of the case studies in the repo, a major tech firm is using it to monitor 10 terabytes of log data every single day. They aren't just looking for keywords, they are looking for vibes of system failure.
Wait, vibes? You're going to have to explain that to the folks who are knee-deep in latent space. How does a server log have a vibe?
Think of it like a mechanic listening to an engine. A traditional monitor is looking for a specific clank, an error code 500, or a timeout. But a seasoned mechanic can hear the engine, hunting, or sounding slightly off before anything actually breaks. OpenClaw is doing that with text. If the logs start sounding anxious, meaning the patterns of errors across disparate systems suggest a cascading failure, OpenClaw flags it before the traditional threshold alerts even trigger.
That is wild. So it is not just waiting for a specific error code like a traditional monitor would. It is understanding the relationship between a slight latency spike in the database and a weird memory leak in a microservice that technically hasn't crashed yet. But Herman, 10 terabytes a day? The cost on that has to be astronomical, right? Even with the efficiency gains we have seen lately, my credit card hurts just thinking about the API bill.
You would think so, but the repository highlights a shift in token economics. Because OpenClaw is so efficient at high throughput, the cost per token processed for these background tasks is actually dropping below what it costs to run traditional, heavy NLP pipelines that require constant fine-tuning. One startup mentioned in the repo is using it for automated legal document analysis. They reduced their review time by 90% because they aren't paying humans to do the first 3 passes of, is this even relevant? They just let the token eater chew through the discovery pile.
I love the term token eater. It sounds like a monster under the bed for cloud architects. But let's get into the actual awesome use cases that regular people, or at least very nerdy people, are implementing. I saw something in there about an overnight mini-app builder. That sounds like the ultimate procrastinator's dream.
This is arguably the most magical implementation in the whole list. They call it the self-directed employee. The idea is that you don't give it a specific task, you give it a brain dump of your long-term goals. Say you want to launch a software as a service by the 3rd quarter or grow a YouTube channel to 100,000 subscribers.
And what? It just sits there and thinks about it. Does it give you a motivational speech every morning?
No, it actually works. Every morning at 8 a.m., the agent autonomously generates 4 or 5 tasks to advance those goals. But the kicker is the surprise element. It is programmed to build a surprise mini-app MVP overnight. It looks at your personal problems. Maybe you mentioned in your journal or a Slack message that you hate how you track your workouts or your grocery list, and you wake up to a finished working prototype on a Next.js Kanban board.
Wait, so I go to sleep, and while I am dreaming about sloths and eucalyptus, this thing is actually writing code, setting up a database, and deploying a functional app? That is a bit terrifying, Herman. What if I wake up, and it has built a sentient toaster that refuses to brown my bread until I solve a riddle?
Well, it is not quite Skynet yet. Technically, it uses a state.yaml or autonomous.md file to track its progress. It is basically keeping a diary of what it tried, what failed, and what it decided to do next. It is using those 16 trillion tokens to simulate the trial and error process that a human developer goes through.
How does it actually handle the decision-making, though? Does it just guess what I want?
Not exactly. It uses a recursive feedback loop. It scripts out a feature, runs a local test, sees the error message, and then rewrites the code. It's essentially brute forcing the creative process. I saw one example where it tried 17 different ways to center a submit button before it found one that didn't break the mobile view.
I am looking at the technical details for that one now. It is fascinating how they handle the memory aspect. They mention a token-light strategy. Instead of the agent reading its entire history every time it does something, which would be like you reading your entire autobiography every time you wanted to make a sandwich, it archives old tasks and keeps the active memory file under 50 lines. That is clever. It avoids that AI fog where the model gets confused by too much context.
It is essential for long-running agents. If you don't prune that context, the model starts hallucinating or getting stuck in loops. It's like a human who can't remember why they walked into a room because they're too busy thinking about what they had for lunch 3 years ago. Another use case that really caught my eye was Nathan's self-healing home server, which he calls Reef. This is for the people who run their own home labs or Kubernetes clusters.
Oh, I know the type. They spend all weekend fixing their server so they can spend all week using the server to fix the server. It's a self-perpetuating cycle of digital masochism.
Guilty as charged. But Reef turns OpenClaw into a 24/7 system administrator. It has SSH access to the machines and commands for the clusters. It runs a cron job every 15 minutes to check the health of every service. If something is down, it doesn't just send you a help me text. It actually reads the logs, diagnoses the issue, and applies the fix. It might restart a pod or fix a corrupted configuration file autonomously.
Okay, but let's talk about the giant elephant, or donkey, in your case, in the room. Security. If this thing has SSH access and it is autonomously fixing things, what is stopping it from accidentally opening a hole in the firewall, or, even worse, hard-coding my passwords into a public script? Can it distinguish between fixing a bug and accidentally inviting the entire internet into my home network?
That is actually one of the big lessons learned in the repository. They found that AI will happily hardcode secrets if you don't give it guardrails. It's too helpful for its own good. So, the implementation requires something called TruffleHog for secret scanning and a local first get workflow. The AI can play around in the local repo all it wants, but it is physically blocked from pushing to a public repository without a human hitting the yes button. It's basically putting the AI in a sandbox with a very strict babysitter.
That makes me feel slightly better. Only slightly. I also saw a section on AI video editing via chat. Now, as someone who finds video timelines to be a form of modern torture, just moving those little blue bars back and forth for hours, this piqued my interest.
This is a huge one for content creators. You basically bypass the entire GUI of something like Premiere or CapCut. You drop a raw video file into the chat and say, trim this from 15 seconds to 90 seconds, add some upbeat background music with audio ducking, and burn in English subtitles. OpenClaw then generates the FFmpeg commands or uses its own internal processing to spit out the finished file.
And it can do batch processing, right? Like, take these 10 vertical videos for TikTok and make them all look professional.
Oops, that is correct. It can handle entire folders. It can crop 10 raw clips to 9:16 vertical for TikTok and add auto captions to all of them simultaneously. It is removing the manual labor of editing, which lets the creator focus on the actual ideas. Think about the time saved. A task that used to take a human editor 4 hours of clicking and dragging now takes OpenClaw about 30 seconds of computation.
Does it understand the vibe of the music too? Like, if I'm showing a sunset, is it going to pick heavy metal or something lo-fi?
In the awesome repo, there's a project called MoodSync that does exactly that. It analyzes the visual frames for color temperature and movement speed. If the video is fast-paced with lots of cuts, it selects high BPM tracks. If it's a slow pan over a landscape, it goes for strings or ambient pads. It's essentially a creative director in a box.
I have to say, Herman, I am impressed. I thought this repo was just going to be people making more chatbots, but these are actual infrastructure-level tools. It is like we are moving away from AI as a toy to AI as the plumbing. But what about the friction? There has to be a catch when you have multiple agents working together. We've all been in group projects where nothing gets done because everyone is waiting for someone else.
There is a really interesting technical hurdle mentioned called the race condition problem. Imagine you have a team of agents, say a researcher, a writer, and a designer, all working in a Discord channel. They all want to update that autonomous.md file we talked about earlier to show their progress. If two of them try to write to it at the same time, you get a silent failure, where one agent's work just disappears into the ether.
The classic too many cooks in the kitchen problem. But the cooks are all high-speed neural networks. How did they solve that? Did they give them a talking stick?
Sort of. They moved to an append-only log, very similar to how Git's commit history works. Instead of editing a single file, the agents just keep adding new entries. It prevents them from overwriting each other. It is a simple solution, but it shows that we are having to reinvent basic computer science principles specifically for AI to AI collaboration. We're building a new kind of operating system where the primary users aren't humans, but other models.
It is funny how everything old is new again. We are literally gitifying the thoughts of AI agents. But let's talk about the bugs first policy. I saw that in the autonomous game dev pipeline section. It is a strict rule that the agent is forbidden from building new features until it has scanned the existing code and fixed all known issues. We could use that in the human world, couldn't we? Imagine if developers couldn't add a new emoji to an app until the login screen actually worked every time.
Every software engineer listening to this right now just nodded their heads so hard they got whiplash. It is a brilliant constraint. Because OpenClaw has such high token throughput, it can afford to obsess over the code in a way a human wouldn't. A human gets bored of QA. A human wants to build the fun stuff. But the AI doesn't get bored. It can run thousands of simulations to see if a new feature will break something 5 steps down the line. It can basically play test a game 1,000,000 times in an hour.
It is basically a QA department that never sleeps and doesn't complain about the coffee. But let's pivot to something a bit more practical for the average listener. The event guest confirmation bot. This sounds like something that would actually save me from a nervous breakdown if I were planning a wedding.
This is a great example of multimodal autonomy. You give the agent a list of guests. It uses AI voice integration to actually call each guest one by one. It confirms if they are coming, asks about dietary restrictions, and then compiles all that into a structured summary for the caterer. It is essentially a robocall assistant that isn't trying to sell you a car warranty.
See, that is where it gets a little uncanny valley for me. If I get a call from an AI asking if I want the chicken or the fish, am I going to know? Or is it going to sound so human that I end up telling it my life story and why I'm still mad at my cousin Vinny?
Given the current state of voice synthesis in 2026, you probably wouldn't know unless it told you. But that is the power of this framework. It is bridging the gap between digital data and real-world action. One project in the repo even uses this for elderly check-ins. It calls seniors living alone, has a 5-minute chat about their day, and if it detects signs of confusion or physical distress in their voice, it alerts their family.
That's actually quite moving. It turns the token eater into a token caregiver. But Herman, we keep coming back to this 16.5 trillion number. How does the physical world even support that? Are we just building massive data centers in the middle of the ocean at this point?
Pretty much. I think the most important takeaway from this repository isn't just the cool projects, though. It is the shift in how we think about AI infrastructure. We are seeing a massive demand for specialized hardware, TPUs and custom ASICs, just to keep up with these use cases. If you are a developer, you can't just think about how do I prompt this model. You have to think about how do I optimize my token consumption so I don't go broke while my agent is building me a surprise app.
That is the second order effect that people often miss. OpenClaw's dominance in token consumption isn't just a vanity metric, it is creating a new benchmark for the entire industry. If your framework can't handle 16 trillion tokens with low latency, you aren't even in the game anymore. It's like trying to run a modern city on a single water pipe from the 1800s.
And the awesome repo shows that the bottleneck is no longer the AI's intelligence, but our ability to provide it with enough work surface. These 47 projects are just the tip of the iceberg. We're seeing token as a service becoming the new software as a service.
So, if I am a listener and I want to get my feet wet with this, what do I do? Aside from heading over to Hisam Shaik's GitHub and staring at the code in confusion until I feel like a failure,
The best thing to do is experiment with a small-scale project. Don't try to build a self-healing Kubernetes cluster on day one. Try setting up a simple autonomous agent that manages a single task, maybe just summarizing your daily emails into a briefing gateway style report. Get a feel for how the autonomous.md file works. Once you understand the loop of observe, plan, execute, then you can start looking at these more complex, awesome use cases.
and keep an eye on that repository. With 47 projects already, and the way this community moves, it will probably have 100 by the time we finish this recording. It is a living document of the AI revolution. I wonder what number 48 will be. Maybe an AI that listens to podcasts and tells you which parts to skip.
Hey, don't give them any ideas. We need those listeners. But seriously, it really is impressive, and it is refreshing to see people building things that are actually useful, rather than just generating pictures of cats in space. Not that there is anything wrong with cats in space, but I would much rather have an agent that fixes my server while I sleep.
Spoken like a true nerd, Herman. I don't want art. I want a stable Kubernetes cluster. I think that is a perfect place to wrap up our deep dive into the token eater's favorite recipes. It's clear that OpenClaw isn't just a model anymore, it's an ecosystem.
I agree. It has been a fascinating look at the how behind those 16 trillion tokens. There is so much more to explore in that repo, including some of the crazier stuff like the autonomous stock portfolio, which we didn't even have time to touch on, though I'd advise people to be very careful with that one. I highly recommend people check out the link in our show notes.
Definitely. Don't let the AI spend your 401k just yet. Well, that was a lot of ground covered. My brain feels like it has consumed a few trillion tokens itself. I might need a reboot.
Mine too, but in the best way possible. It's an exciting time to be a builder.
Thanks as always to our producer Hilbert Flumingtop for keeping the wheels on this bus and making sure our own race conditions don't end in disaster. And a big thanks to Modal for providing the GPU credits that power this show and allow us to dive deep into these technical topics.
This has been My Weird Prompts, episode 1955. If you enjoyed the show, please consider leaving us a quick review on your podcast app. It really does help us reach more curious minds and keeps the token eater fed.
You can find us at myweirdprompts.com for the RSS feed and all the ways to subscribe. We will see you in the next one.
See ya!
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth